So here we have 20 bowlers, of which, and their games. So here we have 20 students, and we are trying to determine if this 15-minute coaching session impacts their bowling scores. So what we've had the students do is we've had them bowl one game, and then we've given them a 15-minute coaching session, and then we're having them bowl a second game. The null hypothesis is that there is no significant difference between students' bowling scores before and after the coaching session, while the alternative hypothesis is that there is a difference between the bowling scores before and after the coaching session. I know if I was in charge of this coaching session, I would hope that there would be a positive difference, meaning, an increase in scores following the coaching session. The first things we have to do is we actually have to determine what the difference is between the two games. So what I'm going to do is I'm going to click transform, and I'm going to click compute variable. And what I'm going to do is the target variable, I'm just going to say difference. And then I'm going to do game 2 minus game 1. Then I'm going to say okay. I think it figured that it add this up. So we're seeing that this score increased by 18, this score increased by 30, this score increased by 5, this student did worse, this student did worse, etc. So just to make sure that the numbers are actually working. So now the next thing I'm going to do is actually going to analyze the difference variable. What I need to see is if that's a normally distributed variable. No, that's not it. Actually, I do want that. I do want the mean. And then I want to do a chart. I want to do a histogram and then show normal distribution. Continue and then say okay. So we're seeing that the mean is 4.95. That's the difference. And then there's a standard deviation of 13.13. We're looking at the histogram. It looks pretty normal. Yes, there's like some blink in there, but it looks pretty normal. So I'm going to proceed. Additional way that you can test for normality. I'm going to go to descriptive statistics, explore. What I'm looking for is difference, and I'm going to go to plots, and I do histogram, normality, plots with tests, continue, run that. And what we're looking for is the Shapiro-Wilk significance to be greater than 0.05, which it is. So that's great. So we're able to work on this as normal. The next thing we're going to do is we're actually going to run the paired t-test. So we're going to click analyze. We're going to click analyze, compare means and proportions, paired sample t-test. I'm going to bring game 1 and game 2 into there, and I'm going to hit OK. Let me see if there's any interesting options. We're doing a 95% because our alpha has to be 0.05, and then we're going to say continue. Then we're going to say OK, and we're running it. So here are our results. So you are going to see on my screen two different t-test runs. And the first one, I had variable from game A in the first column and variable from game 2 in the second column. And what I found was negative mean, and so it kind of made my brain hurt a little bit. But you're going to see that the numbers all pretty much match, but this just makes the data seem to make more sense. I put game 2 in the first column and game 1 in the second column. And what that gave me was the mean of 94.95 for all of game 2 scores, 90 for all of the mean scores, or the mean score for game 1 for the 20 students. It gives me the standard deviation there. Ignore the paired samples correlations. And what we're looking for is the paired samples test. So the mean difference was 4.95 with a standard deviation of 13.137. And you're going to see the numbers that matter are the T, the DF, and the one-sided p-test significance. So you're going to see that the t-value was 1.685. The degrees of freedom is 19. And then we're going to see our significance as being 0.054, which is just over the notch, or just over by a notch of the result that would cause us to reject. That would cause us, to reject the null hypothesis, because we're looking for that number to be 0.05. So it's slightly over that. What that means is that there's 5.4% chance that the improvement in scores was basically just a fluke, and so it's not that number is not low enough for us to accept or to fail. That number is not low enough for us to reject the null. We're looking at the 95% confidence interval here, and what's very interesting about this is when you're looking at Boolean scores, there is, if you're looking at the impact of this training, it is well within the 95% confidence interval that you might actually do worse, because you're looking at lowering your score by 1.198 points. So the impact of this training, that's what that 0.004 means, is there's the chance that you're actually going to do worse. So looking at it from that perspective, it's just a different way of looking at these numbers. So it's so close, but yet it's so far. Now, granted, it's only a 15-minute training, and you only did this with 20 students. It may be valuable to actually do this with another group of 20 or another group of, say, 40 to 50 students, and to see what the impact is. Is there anything you can make this 15-minute training into a 20-minute training to see if if it can have a positive impact? In the grand scheme of things, it's only 15 minutes. So the delta percentage is 5.21%. What I did was I took 94.95 minus 90.0 and then divided by 90. So that gets you to 5.21%. In order to assess the efficiency of the bowling training we provided to students, we gathered data on 20 students' bowling scores before and after the training. The mean of the scores in the first game was 90. The mean of the scores in the second game was 94.95. You'll notice that is a difference of 4.95 more pins knocked down in that second week. This increase in pins, though, is not statistically significant, with a p-value of greater than 0.05. The t-value was 1.685. The degrees of freedom was 19, and we failed to reject the null hypothesis, and we can only assume that the difference in the Boolean scores was not significantly attributed to the training that we provided to the students. I had to do a little bit of digging on this. I was confused about the one-sided versus two-sided thing, and so I wanted to look back at what my null hypothesis was, and because my null hypothesis specifically said that there would not be a significant difference, not that there would not be not that grades would improve, or not that scores would decrease. I specifically said not a significant difference. I have to actually look at the two-sided p, and what that does is that makes things even worse, I guess, if you want to say it that way. That because the two-sided p is 0.108, it's not within throwing distance of the 0.05 significance. It's nearly double that. So I'm going to wholeheartedly fail to reject the null hypothesis and I'm going to say that there's no significant difference between students' bowling scores before and after the coaching session.